just pay attention, everyone. When you have a number by itself and there is no exponent explicitly written, it is implicitly implied that there is an exponent, and that exponent is 1. So just remember that. So I'm going to say this a few times, but hopefully you will get it eventually by the end, that a number by itself has an exponent. It's not 0. And I'll give you a reason why that makes sense. Hopefully you remember this rule, that anything to the power of 0 is equal to 1. Okay, so once again, exponent is 1 when there's nothing written, and the rule is if I have anything to the power of 0, let's say if I have x to the power of 0, that's 1. If I have 100 to the power of 0, that's 1. If I have 256 to the power of 0, that's equal to 1. So the rule is if anything is to the power of 0, it's just 1. That's just the rule. So you cannot have 4 to the power of 0 here, because we know that the denominator is not 1, it's 4. And the only way to do that is to have an exponent of 1. It's kind of like multiplication. This is exactly like multiplication. It's like if I have 4 times 1, well, that's just 4. If I have 4 to the power of 1, well, that's just 4. Hopefully that makes sense. If not, I'll just keep repeating myself. So let's continue now. This is going to be 4 to the power of 3, 4 to the power of 1. We are now going to subtract the two numbers. 4 to the power of 3 minus 1. That's 4 to the power of 2. That's it. We're done. It says do not evaluate. What that means is we don't have to find the final numerical answer, which in this case would be 16. That means we do 4 to the power of 2 in your calculators. Now this is important because on a test or an assessment, if I get an answer of 16 for something like this, I will give you 0 marks because you're not following instructions. What's the point in having a question and you're not actually doing what the question is asking you to do? Think about it. The question asks you to do something, you do something else. That's a 0. So be very careful with that. I'm warning everyone right now. So important thing to note. Because a lot of students, they just punch stuff into calculators. They get a number answer and they just put that number in. And they don't even realize what the question is asking. So that's what that means. Simplify means to leave it like this. Do not evaluate means to leave it like this. Now, if it says evaluate, then your final answer should be 16. But you still have to show your steps for full marks. For example B here, we have -5 in brackets to the power of 5 divided by -5 in brackets to the power of 5. So the base number is the same. In this case, the exponents are the same. That doesn't really matter though. We're just subtracting 5 minus 5. What does that mean? Well, 5 minus 5 is just -5 to the power of 0. That's the answer. Now, if it's set to evaluate, I just went over this rule, but I'll repeat it. Anything, any number, any letter, to the power of 0, it's 1. So we're not going to write equals 1 because we want to keep it as a simplified version. Now 6 to the 3, or 6 to the 9. Alright, so 6 to the power of 3 divided by 6 to the power of 9. Remember, it's always the top number first, so it's going to be 6 to the power of 3 minus 9. And hopefully you can see that that's going to be 6 to the power of -6. And here's our first example of a negative exponent. Are we allowed to have negative exponents? Yes, we are. We are even allowed to have fractional exponents, meaning your exponent can be a fraction. So negative exponents are totally fine. Just leave it right now for like this. I will teach you what to do with negative exponents, probably in the next slide, or somewhere in this lesson, if not the next one. Yeah, no, this is the power rule. We're going to get to that rule in a bit. What to do with negative exponents. Okay, here we have an example. What's this called? The power rule. Power rule. What does power rule mean? Okay, so power of a power rule, what that means is when you have an exponent, a base number with an exponent, and then what you do is you take that whole bracket and you raise it to another exponent. So this is going to be 4 to the power of 2 to the power of 3. So how do we do that? Very simple. When applying an exponent onto a power, you multiply the exponents. So this is going to be 4 to the power of 2 times 3. That's what you do. So this is 4 to the power of 6, not 5. 2 times 3 is not 5. 2 times 3 is 6. That's the answer.
Daddy, it's black with blue.
Okay, baby, okay. Okay. So let's do some examples. 4 to the power of 4 and then to the power of 6. So that's going to be 4 to the power of 4 times 6. Now hopefully you see the pattern here. The first example, the first rule or law, whatever you want to call it, we added the exponents. It's called the product rule. The next one was the quotient rule, where we subtracted the two exponents. And now this is the power rule, and we are multiplying the two exponents. Some basic math, nothing too complicated. We're literally just adding, subtracting, and multiplying. That's how easy this is. This, though, this is tough. When you have multiple brackets, that's annoying, because you have to keep track of what's happening. But this isn't too difficult. There's only two brackets. The first bracket just has the negative 5 in it, so there's really nothing going on, except to say that that 5 is a negative number, and it's being raised to the power of 5. And then the second bracket has a negative exponent. So I'm not sure why we aren't teaching you the negative exponent law while having examples of it. So I will skip this for now, and I will show you what the negative exponent rule is. So here is the zero exponent rule. Before we move on, this is the easiest one. I think every student gets this one. This is not hard. Anything to the power of 0 is equal to 1. Very easy. We'll even do the examples for this one. I'm going to ask the class the answer. No need to be shy. We'll pick 3 different people. All right. Class A. Type in the chat, someone. What's the answer to 42 to the power of 0? Congratulations, everyone got it right. That one was an easy one. This is probably the most difficult rule, I would say, for students to wrap their heads around. The negative exponent rule. Any power with a negative exponent is equal to the reciprocal of the power with a positive exponent. What does that mean? Some big words here. Positive, negative, equal. You know what? Reciprocal. Anyways. 4 to the power of negative 3. If I wanted to rewrite that with a positive exponent, I need to take the reciprocal. The reciprocal means you flip the fraction. What if there is no fraction? Well, make a fraction. Any number can be written as a fraction. Remember? So flip that fraction. Yep. So what happens is this. You flip that fraction. 1 over 4. Now the question is, where does that 3 go? Remember now that 3 is a positive 3 because we did the reciprocal. I'll give you a hint. Exponents can never change their base number. So what base number had an exponent? Did the 1 have an exponent or did the 4 have an exponent? Perfect. The 4 had the exponent. So that means in this fraction now, which number is going to have the exponent? The 1 or the 4? Perfect. Both of you. Thank you. Thank you, both Zara and Ashant. Yes. The 4. So the answer is 1 over 4 to the power of 3. This is how you change from a negative exponent to a positive exponent. This is a negative exponent rule. Definitely going to do examples on this one. And we'll go back to the quotient rule examples. Apply them here. So here we have 6 to the power of negative 2. What is the answer going to be? I want someone from the class, if they're brave enough, to answer. Absolutely right. Good job. 1 over 6 to the power of 2. And then 2. Oh, 2. Thank you, Vivi. 2 is positive. And it says do not evaluate, so we're not going to go further than this at this point in time. What about B? Who wants to do B? Thank you. Anyone? Except for obviously Ashant, who's already. Thank you. So very close, Zara, very close. You probably would have gotten this right. Just make sure you write it exactly like this. So it's going to be 1 over, and see the exponent is to this bracket here. So you have to write that bracket as is. To the power of 4. Important note, the negative sign on the exponent switches to a positive sign, but not the base number. The base number, I'll give you something. An exponent cannot change the positive or negative of a base number. Is that true? Yeah. Yes, exactly. They were either add, subtract, or multiply depending on the rule. Yes. So yeah, so the base number never changes until you evaluate, meaning you take the 4 and then you do -5 times -5 times -5. But at that point, you don't have an exponent anymore. So there's really no base number. You've evaluated it. But whenever you have an exponent, the base number never changes. So in this case, the 6 became a 6, stayed the 6. -5 stayed -5. In all our previous examples, whenever we were simplifying, except for obviously the power of 0 rule, the 4 is a 4. Now here we are back to our example with the power of a power rule. So here we have -5 to the power of 5 to the power of -2, and that's going to be times -2. And 5 times -2 is -10, because 2 times 5 is 10, and then there's a negative, so it's negative. And we're going to take it one step further, and we're going to apply the negative exponent rule. And the final answer is going to be 1 over -5 in brackets to the power of +10. So here's an example of combining a bunch of these rules together. And that's essentially where we're headed. We're going to eventually get to the point where you're going to have to combine all of these rules in one question. So here we have 3 to the power of 3, and then to the power of 2, and then to the power of 4. This is simple because there's nothing else happening, so I know it's just going to be 3 times 2 times 4. It's less simple when there's a bunch of other stuff in those brackets. But if there's just one number, you're just multiplying the exponents. So it's 3 times 2, which is 6, 6 times 4, which is 24. So this answer is just 3 to the power of 24.